Hi, welcome back, and thanks everyone for joining AWS Educate on Twitch. I'm Grace.
And I'm Leo.
And this is the third of our four-part series on the basics of cloud computing, how to use AWS, how to access the console, and really how to use some of the same services that really great companies today are using to build and run just amazing apps on the cloud that are helping with their businesses. So we look a little different this week if you joined the first two episodes. Ken is off. My name is Grace Kitzmiller. I'm the Senior Product Lead for AWS Educate, and I look after our educator, student, and recruiter experiences. AWS Educate is Amazon's initiative to try and accelerate cloud learning in the classroom and really give educators and students the resources that they need to learn the cloud. And I'm here with a familiar face. Leo, can you introduce yourself?
Yeah, so I'm Leo Janowski. I'm a Principal Solutions Architect here at AWS, and I basically help our customers actually implement AWS. I show them which services to use and how to use them, and how to use them the right way, basically.
Great, thanks. Now, before we dive into today's session, I just want to remind everyone that you can join AWS Educate today. Simply go to awseducate.com, and when you get to the registration page, in the promo code box, type in Twitch 2018. That's TWITCH 2018. And when you use that, you'll gain access to resources such as learning content and other resources that you can use to practice some of the activities that Leo showed in the first two episodes and some of the activities that we're going to show you today. Leo, do you want to recap our first session?
Yes, in the first session, we basically set up a website using our simple storage service, S3. So we just set up a snakes game on an S3 bucket, enabled that S3 bucket for static hosting, and demonstrated how that worked. We also talked about how some of our customers like Airbnb and Under Armour use S3 both for backups, for storage, and as data lake solutions to do analytics as well.
Great, thanks, Leo. And in our second session, you took it up in a little bit, right? We dove into serverless, Lambda, used Cloud9 to create a to-do list app.
Yep.
Do you want to talk a little bit about that?
Yeah. So in the last session, we set up a Lambda function, and I don't want to write my own code from scratch, so I took it from the serverless application repository that we have. So I found the to-do function on there, and that used Lambda and it used the API gateway. So API gateway routed my requests from the internet, from my web browser, into my Lambda function. And then we also talked about how to do architecture diagrams using Cloudcraft as well.
Right. Now, Lambda and serverless, there are some companies out there that are, really use Lambda for some amazing things, right?
Yes.
Like Netflix uses Lambda.
Yeah, so we discussed that last time. So, Netflix uses Lambda for a bunch of things like verifying their backups that we talked about. And yeah, we have a lot of customers that use Lambda and serverless technologies in general.
Okay, great. So now this week we're really going to take it up to the next level, right?
Yep.
We're going to build a 3-tier web architecture and going to use things like elastic load balancing, a little bit of auto scaling, elastic beanstalk, and a few other services.
Yeah, so basically, now that we've set up a serverless application, and now that we've set up a website using static hosting, we're going to do what's called like dynamic hosting. And so the example I'm going to give today is essentially going to use EC2, so that's our Elastic Compute Cloud. So it's a virtual server. It's going to have several EC2 instances because we're going to do load balancing between them. So we're going to have at least 2 instances, a load balancer in front of them, right? So that's ELB. And then we're going to have a database. So because, the application we're going to use today, WordPress, it's a LAMP stack, so Linux, Apache, MySQL, PHP, right? So the database is going to be, it's MySQL, right? So that's going to be run by RDS Aurora. And then the actual code, the PHP code, is going to be on an EC2 instance. And then we're going to distribute the traffic among multiple EC2 instances, right?
Okay.
And then we're going to have auto scaling as well. Okay. So let's say we get a lot of traffic, we go from 2 instances to 10 or 20 or however many we need to meet demand, and then we're going to scale back down. So as we get less traffic, the instances are automatically going to get shut off as they're not used. So we save money and we meet the demand that we have. And then on top of that, instead of manually setting all of that up, I'm going to show you how to use our Elastic Beanstalk service, which handles all the auto scaling and spinning up the instances and a lot of that set up for you.
So it takes care of a lot of that automatically once you do some configuration?
Yeah, it's going to be a lot simpler than just me setting all that stuff on your own, which you can and some of our customers do. But I wanted to show you how you can get this up and running really quickly, but still have full control over everything that sets up. Yeah, so that's why I'm doing this.
Now, I think we wanted to talk about a couple companies that make pretty significant use of things like ELB and auto scaling. And one of them is Lyft, the ride-sharing app.
Yes. So Lyft, they use, they have, how many million users? I think it's
18 million.
Yeah.
14 million.
14 million,
million
right?
rides per month.
Per month.
That's a lot of rides.
Yeah, and they're in more than 200 cities, right?
Okay.
So they use auto scaling, right? So basically, again, as they get more rides, or if there's some kind of like a football game or something where everyone's requesting a ride, they can dynamically scale up their demand or their capacity to match the demand, and then they can scale back down.
Okay, great. And then another company that really makes significant use of these services is one I'm really excited about, Epic Games, right?
Yep, so they run Fortnite. So they have over 125 million players, I believe. Yeah. And obviously to host that many players, you need to have, you'd be architected for scale. And so they're using AWS as well, and they're using EKS. So EKS is the Elastic Kubernetes service. Okay. So that is basically a container orchestration system. So they use that to build a bunch of microservices, and again, each of those can be scaled up and down as they need as well.
So you said containers and microservices.
Yes.
Can you tell me a little bit more about what each of those is?
Sure. So a container is basically a stripped down operating system or a stripped down operating system image. So typically it runs Linux or various flavors of Linux or Windows. And the advantage of it is I can create a container on, say, my laptop. And then I can upload that container to a container registry, such as we have the ECR, which is our container registry service. And then I can spin up that container in a Docker cluster. So I can use EKS for that. I can use ECS, which is our other Docker orchestration system. Or I can just spin it up. I can install Docker on an EC2 instance. Anyway, regardless of where I put it, the container is going to work and spin up the exact same way on my laptop or anywhere it's launched. So it's portable, right? So you can use that to quickly get things up and running, and also to build microservices. So a microservice is, instead of having your application as one monolithic piece of code that runs on like a really big server, as you traditionally would do, you basically break up your application into components. So if you think about, like, for example, Amazon.com, each component of when you go to Amazon.com, like, could be one or multiple microservices. And so that microservice just handles, say, like the login button, right? Right? And so what that allows you to do is each service could be built in a different language, right? It doesn't matter. They're just communicating through each other with through APIs, right? And also allows you to have different teams build different services in parallel. They just have to maintain that their APIs are accurate, right?
And that makes your apps and your code much more modular, right? You can swap out and update different pieces.
Yes, and it's more agile, right? So you can build quicker. You can swap out the underlying microservice, how it's built, as long as it interacts with other services the same way. And it's just a more modern way of development. And so because each component is smaller, you can have like a set of Docker containers essentially control each one. You can also, for example, use Lambda for that, right? So you can have API gateway pointing at the Lambda function that does something, and that'll be like a microservice.
Great. Really, really great to hear that. Is there maybe an educational institution you can talk about that uses this kind of architecture? Yeah,
so I actually used to work with a specific institution. So the University of Notre Dame, so they have a website, right? Like their university, exactly. And they had a problem in that every time they had a football game, there'd be a lot of traffic on their website. So people would probably be looking for like where to park or details about the game, the score. And so every time they would have a game, they would get so much traffic that their website would crash, which wasn't good, right?
Not good.
So then they moved their website to AWS. And what they did was actually very similar to what I'm going to show you today. So they set up a 3-tier web architecture. So they have load balancers, so ELBs, they have EC2 instances, an auto-scaling group, they have an RDS instance, so that's hosting their database, and they have auto-scaling configured. So as they get more and more traffic for game day, they just automatically add more instances, and then as the traffic dies down after game day, the instances automatically shut off. So now they don't crash anymore, and they've saved over 50% over what they were spending before with their previous setup. That's a really good example of kind of the benefits that this gives you.
So with ELB, you get the failover in case one of your servers fails, and then with auto scaling, you get the elastic scaling up and scaling down, and you can really optimize what you're spending on your site.
Yeah, so with ELB, you get multiple benefits. So first of all, ELB, just a load balancer, routes traffic between instances. So that could be 2 instances, it could be 1 instance, it could be 100 instances, right?
Okay.
So that's both for scale. So the more web servers you have, the more capacity you can support, but it's also for failover. So if one of those instances fails, it just gets taken out of the load balancer, and the other instances absorb that traffic, and the traffic gets redistributed.
Okay.
And then auto scaling, what it does is auto scaling handles the actual mechanics of like adding instances and deleting them. So for example, if one instance fails, just like not necessarily for traffic, but just like the operating system crashed, right? Yeah. So for whatever reason, the auto scaling group will detect that. It'll shut it down, and it'll launch a new one, right?
Okay.
So regardless of why it goes
Recovers
down, what it does is you have a minimum set of instances in an auto scaling group and a maximum. And so it's going to make sure you have at least the minimum and no more than the maximum, and then it'll move between that based on scaling triggers that you've set up. So that could be like CPU usage, it could be network traffic, it could be a custom metric. So you tell it when and how you want it to scale up or down.
Okay. All right, great. Well, all that's really helpful, but why don't we dive into the demo? I know you've got some really great things to show us today.
Yeah, so let's share my screen here. Today, again, I'm going to be using AWS Cloud 9 just to kind of orchestrate this demo. So in my Cloud 9 environment, I showed you previous weeks how to spin that up, so I'm already in my environment. And all I've got here is I've got my WordPress in here. And so let me actually see if I can make this a little bit bigger. Here we go. So this is just your standard WordPress. So I just went to the WordPress website and downloaded the file here and extracted it into this folder. That's all I've done here. And so I'm going to deploy from here, but let me talk about that in a little bit. So the first component that we have is an EC2 instance. So if I wasn't doing all this like auto scaling and load balancing, if I just wanted a web server with WordPress on it, what I would actually do is just launch an instance. So I'm going to go to the launch instance screen here. I'm going to select the Amazon Linux machine image. I'm going to do a T2 micro, which is a pretty small instance size. So here it just asks me for options, right? So I can launch it into an auto-scaling group. Again, I'm not going to do that yet, but I pick which network I want it to be on. So I'm not going to actually touch any of these options. These are all going to be defaults here. I'm going to keep the default storage, so I'm going to have an 8 gig volume here. And I'm just going to give it a name. So my name is going to be test EC2 instance. And then I want to configure a security group. So this basically tells me what ports are open, right? So by default, everything is closed. So I need to get into port 80, for example, to get into the web server. So what I'm going to do here is demo security group. I'm going to give the security group a name. And I'm going to switch this to HTTP. So now I have the port 80 open, so I can get to web server running in here, and then SSH. So I have to be able to like remotely access this instance. So I'm gonna open up port 22. Now in real life, don't ever do this. Don't open up every port from port 22. I'm just doing it just for speed's sake, but I would lock it down afterwards. So I'm gonna launch this instance. And then I'm just going to pick this is a key pair, so this just lets me SSH in. These are my credentials. So it's going to launch this instance. That'll take a minute. Let's actually go see how that works. So the instance is pending right now, so we can see it here. So while we're doing that, I spun up an instance just a few minutes ago. So let's actually SSH into that one just to double check that it works. So I'm going to go back to my Cloud 9 environment. I'm going to SSH into it. So I've copied the host name. There we go, and I'm in. So Cloud9 has a built-in terminal, so I didn't have to install anything on my laptop. I just installed the same key pair that I launched the instance with on this Cloud9 environment. So now I'm in the instance. So now if I were just installing WordPress on here, what I would do is I would download this WordPress tarball, so the zip file, and I would extract it. And I'm not going to go through all of it here, but basically, this is just like installing WordPress on any server. Now, the disadvantage of this is if I do this, I have my WordPress, I have my database, I have everything running on this one instance. So if you know, it just fails, I'm out of luck. If I get too much traffic, like if this website gets popular, I'm out of luck. So basically, this is one big single point of failure, which I don't want. So what I'm going to do instead is I'm going to set up multiple instances, so at least 2 instances. I'm going to set up a load balancer in front of it. I'm going to set up RDS, which is our managed database, in front of it. So RDS is the relational database service. So let me actually go ahead and launch the console for that. So I'm going to go to Services. I'm going to go to RDS. And so this is the RDS console. And I'm going to click Create Database. And so in here you can do MySQL and Oracle and SQL Server and Postgres. I'm actually going to do Aurora. So Aurora is a Postgres and MySQL compatible database engine, but it's enterprise class. So there's a bunch of advantages of it, like you can have up to 64 terabytes of storage, and you can have up to 15 read replicas. I'm not going to get too deep into it, but this basically sets me up so that I can scale in the future. And then I'm just going to choose I want it to be MySQL 5.7 compatible. And I'm going to click Next. So I'm just going to pick a instance size. So because I'm still testing, I'm going to choose a small instance size. But I do want it to be multi-easy. So now multi-easy means I'm going to have a replica of this database. So if this database instance fails, it'll just fail over to the replica. So the nice thing about that is, so if you think about it now, I have the ELB is automatically built to be multi-availability zone, right? So it's using 2 AZs. So if one ELB in one AZ fails, it's going to fail over to the other AZ. EC2, right? I'm going to have an auto-scaling group, so I'm going to have more than one instance and more than one AZ. And AZ, by the way, is availability zone. So it's essentially a different data center in the region in AWS. And then my database is also going to be basically failure-proof. So I'm going to give my instance a name. So educate demo. I'm going to give it a username. I'm going to give it a password. Let me just type in a password here. And then I'm going to get to this advanced settings screen, and I'm not going to change anything here. This allows me to set up some networking options. And then you give the cluster a name. So I'm not going to choose one. It'll do one by default. I'm going to give the database a name. And basically defaults for all these other options, which we're not going to get into here.
Okay, actually, Leo, I have a question for you from PD Drama. And that is there a recommended number of instances behind an ELB?
Basically, you would want, if you have an ELB, like ideally you want at least 2 instances, because the whole point of a load balancer is that it balances across multiple instances. And I would say if you have 2 instances, you should have them in 2 different availability zones, because it's the same cost to have 2 instances in one availability zone and 2 instances in 2 availability zones. So if you're in 2 availability zones, then not only can you survive one instance failing, but you can survive something happening to that availability zone. So now you're across data centers, which is really nice.
Where are the availability zones located?
So they're in one of our regions. So we have 18 regions around the world currently. So for example, here I'm using our Ohio region. In the US, we have a region in Ohio, we have a region in Northern Virginia, we have a region in California, and in Oregon. And then we have a region called GovCloud that's for ITAR use cases, which I won't get into here. But basically, we also have regions on the world. So when you first launch, you pick which region you want to use. And so regions, like you can think of it as different cloud. So each region has its own copy of some subset of our services like EC2 and S3 and Cloud 9. And so you typically pick whichever one is like physically closest to you. And then, you know, if you build a big enterprise application, you might want to consider like going multi-region. But before you do that, you should just use multi-availability zones. So, and if to switch between regions, if we look at my screen here, if you click on here, this is basically just allows me to switch between regions. So right now I'm in Ohio, but if I click on any of these other ones, it'll just take me there. So yeah, so that's what a region is. So I've created my database, and so I'm not actually going to use it here. I just want to show you how to create the database. And so now let's take a look at how do we actually set up this WordPress. So what I'm going to do is I'm going to use Elastic Beanstalk. So Elastic Beanstalk is a service that we offer that basically sets all this stuff up for you. So it sets up your auto-scaling groups, it sets up your instances, it sets up your RDS if you wanted to. It also gives you a bunch of monitoring and auto-scaling management. So it's all in like one service. Now I could set this all up manually by myself, but just to show you how simple this is, I'm going to do that. So I already have this all set up, and I'll show you the end result in a second. But let's set up a new application here. So I'm going to click on. So again, I'm just in the. To get to this, I would go to services and. I'm going to type in Elastic Beanstalk, and if I click here, it'll take me to Elastic Beanstalk. So let's create a new application. Let's do educate.
So that first view showed you applications you already had running? Yeah,
I already have one running. So, but I'm going to create a new one. So now I've created an application. And now I'm going to create a new environment. So I'm going to create an environment. And here you can do a web server environment or a worker environment. A worker is like if you have a batch job that's, for example, doing something like video transcoding. So in that case, you don't need to, it's not exposed to the internet, so you don't need to have a web server or a load balancer.
A load balancer.
So I'm going to do a web server environment. And then on here, you pick basically, you give it a name. Let's educate demo 2. I'm going to skip the description. And so here you choose a platform. So you can do Docker, you can do Node.js and PHP and Python, all these other platforms here. So it'll set it up for you. That's the really nice thing about this. So I'm just going to do PHP. I'm going to have it deploy a sample application before I choose my existing application. And I'm going to actually go to configure more options. So see, there's all these presets here, so I want to do high availability, right? So I'm going to click on that. So what that's done is it's enabled a bunch of different options here. So it's enabled an ELB, so the load balancer. It's enabled auto scaling here. And it's enabled, again, there's the load balancer setup. So it's going to set up all this stuff for me. And so I'm going to actually hit create.
Okay. So while that's creating, we actually have another question from IRTHme, and the question is the ELB a single point of failure?
No, so the ELB is not a single point of failure. So in the backend, there's multiple ELB instances. So when you spin up an ELB, and then, first of all, there's multiple kinds of ELBs. There's the classic ELB and the application load balancer, the ALB. But either one you use.
Is that like classic Coke and new Coke?
Well, I would recommend just using ALB, right? Because the classic ALB is just what we originally had. But at this point, like in almost every use case, I would use ALB. We also have NLB, which is a network load balancer, but that's something else entirely. So let's say you're using ALB. Basically, what's going on is if you have instances in multiple AZs that it's load balancing between, there's going to be at least one ALB like endpoint in each AZ.
Oh, okay, in each AZ.
Yeah, so it'll automatically, if something happens to either one of those, it'll automatically get replaced or automatically fail over. So it is not a single point of failure.
Okay, great.
So while this is spinning up, let's go to my the environment I had already created before. So as you can see, this is running PHP. Everything's okay. So let's kind of go through the setup here. And so I'm just going to go through some of the configuration screens and show you why it's important. So first, we're going to go to the software screen. So here you just set up, this is like what you typically set up on your web server. So the document root, the memory limit, these are all like PHP specific settings. And then I'm having it stream my logs to CloudWatch logs. So basically I can see like the access log and the error log. So whenever someone accesses my website or there's an error on the back end on the PHP software, I can see that go to CloudWatch logs. So it's streaming. So I don't have to like SSH into the instances to actually get the logs.
So that's great. So you can just automatically have that stored in it, or with some configuration, all of those events that are being generated, you can get stored into a log on S3 and analyze it later?
Yeah, so let me actually show you here. So we can go look at these logs. So this is so here's all my logs from this environment. So there's the access log, the error log. So let's look at the access log. And there's a different log stream for each instance because I have 3 instances. So this is my actual access log, right? So I can see it's mostly my ELB health checking that this instance is still there. But these are the actual logs. So the nice thing is, like, I can examine my traffic and I don't have to SSH into either of the instances. I can just go look through this.
You can see how many people are accessing the site or how many errors are being generated just directly from here.
And if I wanted to, I could send these logs to S3 from here. I can send them to like an Elasticsearch cluster if I have that. So you can send these logs from CloudWatch logs into like other services for analysis. And then I have, so these are my environment variables. So basically, I don't want to store like my password, which you can now see here. That's okay. But my host name, my database name, my username, I don't want to store those in my code, right? Because that's bad. Because then if my repository leaks or something, somebody gets access to it, they have my username and password, they can get into my database. So what I'm doing instead, and this isn't probably even the best option to do it, but I just did it for speed, is I use these as environment variables. So if you look in my config file in WordPress, it's actually referencing these variables, not the values of them, right? And so I have those set here, but we also have something called parameter store and secrets manager, which you can now use for this as well. So these are the software settings. So then in terms of instances, I'm just picking, this is where we pick like the instance size, the, how much storage it has.
And that's the EC2 instance size?
Yeah.
Okay.
And the security groups. So I'll show you the security, but the security groups again just basically let you open up like port 80, port 443, so you can actually get to them. And then this is the capacity part. So as you can see, I have a load balanced environment. So that means that it's instead of being in a single instance, there's a load balancer. And here I define the minimum number of instances I want and the maximum. So I have a minimum of 3.
Okay.
Because I'm in 3 availability zones, so I want 1 per availability zone at least.
All right, that makes sense.
And then I have a maximum of 12, so it's a multiple of 3, and I figured, okay, I probably wouldn't need to scale up above that.
Would that typically be like 4 per zone, or it just depends?
I just
on
want
what
it
the
to be,
requirements are?
it just depends. You can set the maximum to anything, really. I just did it, so it makes sense. And then you set up the scaling triggers. So this is like, when does it decide to scale up or scale down, right? So you could do for your metrics, you could do like healthy host count, latency, how much network traffic is going out of them. I did CPU utilization, right? So basically, I'm saying that if the average CPU usage in a 5-minute period is over 75%, it's gonna, so that's across, the average across all my instances. So let's say I have 3 instances right now. It's gonna add another instance. So obviously that'll take the average down when it's spun up. So it'll keep adding instances every 5 minutes until the average CPU usage is below 75%. So that's how it knows, oh, I still need to keep scaling. I'm getting more traffic. And then if it's below 30%, for 5 minutes, it'll take out one of the instances.
And that's why, so for the company Lyft that we talked about before, if a sporting event ends and suddenly you have thousands of people calling for rides, setting up your parameters here will show, the servers are starting to carry a lot of load, so we should spin up another server to manage that traffic and respond.
Yeah, and they might be using some other, like they're using containers, and they might be using some other, metric to scale up and down, but the principle is still right.
It'll be the same. Okay.
Yeah. And then you can also do time-based scaling. So if you know that you have something coming up, like you're
Super Bowl Sunday.
Yeah, or like you're an education company, like 9 a.m. school starting, I'm gonna, need to spin up. So you can configure it to just do something based on time.
Okay.
So again, you can do all of this just in like outside of Elastic Beanstalk. That just gives you a central place to do it, so it's easier for this demo.
Okay. We actually have another question from IRTH Me. and it was, how is the PHP session maintained across multiple EC2 instances?
Yeah, so that's actually a great question. So you have to set that up in your software. For WordPress specifically, which I'm doing here, it doesn't matter because my session is stored in a cookie, which is on my browser. Basically, yeah, the point is that this brings up is my instances are ephemeral. So that means that I have 3, but I might have 6, and these 3 might disappear. So I can't run under the assumption that my EC2 instances are going to keep existing, right?
Okay.
Like they might disappear at any time. So that means anything like logs, session state, static assets like pictures cannot be on those instances because they're going to disappear. So there's several solutions for that. For the static assets part, you can either put them into S3, and there's plugins for that.
Okay.
You can set up, we have a service called EFS, Elastic File System. So that could be like a shared file system that exists outside of the instances that you can upload those static assets to. For session state, typically you store those either in your database, so in RDS Aurora, for example, or in something like Memcached or Redis, which is a shared cache, a caching system. And we have a service called Elasticache for that. So Elasticache is like RDSs for databases. That's for Redis and Memcached. So those can store your sessions. So yeah, the answer is you have to store your session state outside of your instances.
Okay, great. We have another question here from PCIS NERP, and that is, how can I test the load balancer in a staging environment or any other environment, like sending many requests to the site and see how the ELB handles it? Like, how do you test ELB is working?
That's a wonderful question too. So basically, what you can do is what I haven't shown you here so what I've set up here is actually another product called Code Pipeline.
Okay.
And so right now I just have one environment, right? So I have my source code for RDS or for WordPress that is in my code commit repository. So it's in Git essentially. So this is my repository, right? And then what I'm doing here is when I commit, I push to the environment. I have my Cloud9 environment, and in here it's just a Git checkout of my WordPress repo. So let's say I'm going to go into WordPress. I'm going to edit the README file here, or I'll add a new README file. So let me edit that really quick. Okay. And sorry for using Nano here for the editor. So let's see. So I'm going to add this file. Oh, I'm actually on the wrong instance. Okay, so. Okay, so oops. Okay, so. And I'll show you how this answers the question in a second. So, okay, so I've pushed this change, right? And so what that's going to do is in Code Pipeline, this is going to pick up my change in a second, and as soon as this does that, it's basically going to take that commit, zip it up into a zip file, and pass it on to my Elastic Beanstalk for deployment. Now, if I wanted to have like multiple environments like staging and production, what I would actually do is before going to my production WordPress, I'd add another stage here. And so I'd have another whole environment. So it'd be another load balancer, another auto scaling group. So in an Elastic Beanstalk, you can actually set up multiple environments. So this is one environment, but I could add another environment on here and deploy to that. So I would have like a staging environment. So it's going to be set up the same exact way as my production environment. And so again, that'll be another duplicate set of resources. And then I can load test that. And again, because it's not my production environment, I'm not that worried about breaking it. And so what I would do here is, for example, I could deploy some code here. It could go to my staging environment. It'll get deployed. It can trigger load test, or you can initiate a load test, and then after the load test passes, only then will it go to my production environment. So yeah, so to answer the question is how can you test it? I would set up a replicated environment of your production environment. The nice thing about like the cloud and AWS is it's a lot easier to just get a duplicate set of everything, right? You can script that. You don't have to like physically have 2 of everything, and it's a lot easier to replicate. And then for load testing, so actually WordPress has a bunch of built-in load testing tools. So let's say I wanted to add a load test here. You could actually, for example, BlazeMeter is like a third-party load testing tool. So you could trigger that. There's JMeter, like open source tools like that. So it's really up to you how you do the load test.
Great. Thanks.
Cool.
That's it for right now.
Yeah, okay. So where were we? So yeah, we were going to, we were walking through the options here for WordPress. So the other thing I could configure here is what kind of load balancer I have. So like I mentioned, I'm using an application load balancer here, but you can also use a classic ELB. You can configure whether you want like port 80 or if you want SSL enabled, like port 443, and all that stuff here. You can also enable in the configuration how deployments work. So do I want these deployments to go all at once? So I have 3 instances. And I'm deploying code. And in production, I probably don't want them to go all at once because what if that deployment's bad? Yeah, it's going to break all of them. So instead of all at once, I could do rolling. So rolling, basically, what it does is it'll say, update 1/3 of mine, so one of my instances at a time. And then if something fails, it'll just stop.
Okay.
Yep. And so you can also do immutable, which is actually, this is my favorite option. So immutable means it's not going to touch my old instances. So my other 3 instances are going to stay there. It's going to spin up 3 new instances.
Oh.
It's going to deploy to those instances. And if that passes, if that works, then it's going to shift traffic from my old instances to my new instances.
Okay. So it's a really phased approach.
Yeah, and it's immutable, meaning like it doesn't touch what I already have running that's working. So worst case scenario, it just never shifts traffic from my old instances. And so we know the deployment's not going to break anything.
That's great.
So that's the deployment part. Then for security, I'm just gonna, you can give your instance an IAM role, and this is the key pair, so this allows me to SSH into those instances. And then you can, for monitoring, this enables like what it's monitoring for, where it's going to monitor this environment. So again, that was CloudWatch logs, which I showed you a minute ago. And then you can get email notifications, which I don't have configured. So every time there's deployment, it'll email me. And then here's where you configure like your VPC. So this is what subnets it's in, whether they're public or private.
Okay.
And then lastly, you can configure your database here. So you can actually configure it to spin up an RDS instance for you and take an existing screenshot and all of that. I'm not actually doing that here because I'm spinning up my database because I thought it might be recreating my environment a few times. Okay. So I have my RDS database running separately outside of this, and I'll actually show you that here. So this is the demo we just spun up a minute ago, by the way. It's back up. It's up and running. So this is my cluster here. So this is what I've been using. And so the nice thing about RDS is this handles like all of the backups and patching for me. And if I want to spin up a read replica, so if I want to break out where my database is being read from versus where it's being written to, I can do that. So you can't really auto-scale a relational database as easily, right? So what you typically do is you break out the reads from the writes. Okay. So because some applications just read from the database, so they're read heavy, and the writes happen a lot less often. So you can actually, with Aurora, you can have a separate set of readers, and you can have those auto-scaled.
But what does the consistency look like between the read and the write?
It depends on the application, really, right? Okay. So like WordPress, for example, it's going to be mostly reads, right? Because when I'm accessing the website, like it's just reading stuff from the database. It's only really writing. I mean, there's exceptions, but like when I'm in the admin interface and I'm doing stuff.
Exactly. Right? Okay, that makes sense.
Yeah. So again, right now I just have 2. I have a writer and a reader, and it can fail over between these. And I don't have any auto-scaling policies configured, but I can. And so that's the database part. And let's go to code pipeline. So as you can see, my change that I did 4 minutes ago with the README file, it's already gone through and it's already deployed. So we can actually see, so it's pretty fast. So we can actually see here, if we go to my application, this was, a few minutes ago. So it deployed a new version of the application and it did a health check and everything's okay. So that took about a minute and 20 seconds. So that's pretty quick. So let's see my actual WordPress. Like, does it actually work? So this is it. I already had it up here. But yeah, so it's your standard WordPress. I'm going to go into the admin interface here to make sure that works. Yeah, and I already logged in. That's why it's not asking me for a login. But yeah, this is my admin interface. And if we go to, like the settings, for example, and make this bigger, it's got everything in here. So this is a fully functioning WordPress across multiple instances as well. And so that worked great. So the other thing that I think I haven't shown you is the actual load balancer. So because it's being managed by Elastic Beanstalk, so I'm going to go here, and this is the ALB that I've set up. So as you can see, it says it's active.
Mm-hmm.
It's got, these are the listeners, so it's listening on port 80 and 443. And the targeted group is my 3 instances. So it's these 3 instances, they're all healthy.
Mm-hmm.
They're all in different availability zones. And again, the nice thing is I could have set this up manually, but I didn't. Mm-hmm. Elastic Beanstalk did it all for me. So in fact, if we go to, here's this other environment that I spun up live here. And yeah, it's up and running.
Okay.
So let's take a look at, it's going to have a sample application on it, but this is being served live off of the environment I just spun up. So yeah, so that's basically my demo. Yeah, so I don't think we have any other questions right now. So
Let me check here real quick.
let's see.
No, I don't think we have any other questions, but feel free to send a few more in as we wrap up. You know, really, Leo, thanks for showing this. We actually covered really a lot of ground here today.
Yeah.
There are, you know,
We covered 7 or 8 services
7 or 8
today.
services,
Yeah.
right? And you know what they all build up to, though, are really just showing how you can go from just a static website to adding a little bit of Lambda and serverless, and then really how with just a few services you can really take your app and move it from static to dynamic and really have it serving you know, whatever traffic you might expect. Have it elastically scale up and down, have your load balancer routing your traffic and protecting against you know, failover. And you know, there's a lot of services out there that can really streamline that activity for you, so you don't have to do everything manually like Elastic Beanstalk.
And most companies that I work with on a day-to-day basis, they have some combination of all of this stuff. So they have some things that are in S3 buckets that are being, you know, stored statically, and then they have some things that they use serverless for. So they have Lambda functions and API gateways, and they have some things that are running on EC2 instances and RDS and all the stuff I showed you today. So it's not like you just pick one kind of scenario.
Right.
Most companies use some combination of all of these things.
Okay, great. So, you know, before we sign off today, I do want to remind everyone that you can go to awseducate.com to take advantage of access to AWS resources, either via an AWS promotional credit or a starter account. Go to the AWS Educate website. When you get to the student application, enter the promo code enter the promo code Twitch 2018, that's TWITCH 2018 in the promo code box. And we have some special offers for students that are coming to us through Twitch. We want to thank those of you who asked us a few questions. That was really helpful. And actually, you know, now that we've gone through a couple different layers of you know, building apps on AWS, we'd love to hear, you know, what you might be building, you know, what kinds of things you may have built. So feel free to share that with us on aws-twitch@amazon.com. Tell us about what you're doing. Our next session with AWS Educate on Twitch is scheduled for October 16th. We're going to take this WordPress site that Leo just built, and we're going to add the Poly plugin to it.
Yeah.
Right.
So basically what that's going to do is it'll allow so that visitors can listen to posts directly from the website. So you'll be able to click a button and it'll read the actual post on my WordPress for you.
Okay, great. So that's using the Poly text-to-speech plugin. And I think that also lets you publish directly to a podcast, right? At some point.
Yeah, I'll have to, I believe it does, yeah.
Okay, great. All right, so thanks again, everyone, for joining today, and we'll look forward to seeing you next time.
Thank you.